Alright, so from our last class, we got an expression for M2S and also we got an expression for M2S2. Okay, now today, like I said, we are going to introduce the concept of fractional saturation. So in this video, I will introduce the concept of fractional saturation, then I will derive the complete equation for our day equation for a dimeric protein. Okay, so if you've not seen the last video, I will encourage you to see the last video before you watch this one. All right, now let's proceed. Now, fractional saturation, fractional saturation fractional saturation is represented as what? As Y bar. Fractional saturation Y bar is equals to bound protomer, the bound protomer all over unbound plus bound protomer. All over what? Unbound plus bound protomer. So fractional saturation Y bar is equals to bound protomer all over what? Unbound plus bound protomer. Are you get my point now? So this is what we call fractional saturation. So I believe by now you should have known what are your bound protomer and what are your unbound protomer. What are your bound protomer and what are your what? Unbound protomer. Now, from the last class, if you remember the last class, I said something about our bound protomer. You can see it there. This one was our what? Where is it now? Okay, look at it here. This was our unbound protomer, M2 and what? And M2S, okay? M2 and M2S. While this was our bound protomer, M2S and M2S2. I will show you again. This was our unbound, while this our what? Our bound. So I will just quickly take them out. I will take them out now. So our bound, okay, let me take the unbound first. Unbound protomer is equals to what? Unbound protomer is equals to M2 plus M2S, right? While our bound protomer is equals to what? M2S plus M2S2. Okay, so this for our unbound, while this for what? This for bound. Now look at the equation for fractional saturation. Bound protomer all over what? Unbound plus bound. Okay, so let's now say what? Our Y bar now, which is our fractional saturation, it equals to what? What is it equal to? It's equals to the bound protomer, right? What is the bound? The bound is what? M2S plus M2S2. Okay, all over what's our unbound? Okay, all over what? All over unbound plus bound, right? So what's our unbound there? The unbound is what? M2 plus M2S, right? Then plus the bound now. We've written down the unbound. Next is the bound. So this was our unbound now. So let's write the bound protomer. So the bound protomer is now equal to what? M2S. Look at it here. Plus M2S2. Okay. So from here now we can proceed and quickly substitute what this represents. I get my point now. Before we continue, M2S, I will just write what? Okay, I think there's something we're missing here. Now, when you're writing when you write out this part, this unbound and bound, when you write it out, you will introduce some numbers there. Introduce some numbers in the sense that for here now we introduce 2. I will tell you why I introduce 2. Here we introduce 2. Here we introduce 1. While for this one, I will introduce 1. While here we will now introduce 2. What do I mean by this? It simply means that this one is unbound, Abi. is unbound, meaning it has two free active sites. While this one is already bounded with one substrate and it has just waiting one free active site. In like manner, this one is bound, abi? If this one is bound, how many substrate is it bounded to? It's bounded to just one substrate. While in this case, it is bounded to two substrates. I will say it again. The reason I put 2 here is because since it's unbound, since this region is for unbound, right? It has two free active sites that are yet to be bounded with substrate. While this one have just one left. While for this case, this one is bounded to just one substrate, while yet is bounded to two substrates. So for easy remembrance, just say, once you write out the unbound, just put in decreasing order 2, 1, like that. So for a trimeric protein, it will not be 3, 2, 1. No, when we get there, you understand. So in like manner, for the bound region, it will be increasing, while for the unbound region, it is what? Decreasing. The numbers you are putting are decreasing for the unbound, while for the bound, it is what? Increasing. So let me just quickly ship that into this now. So this was our what? This was our bound, right? So here will be what? 1, while here will be what? 2. Okay. Then this was our unbound. So here will now be 2, while here is 1. Okay. While this one is for our bound. So here is also 1, while here is what? 2. Okay. So at the end of the day, our y bar will be equals to what? Our y bar is equals to what? M2s plus 2m2s2. Okay. All over what? All over 2m2 plus m2s plus m2s. What would that give you? 2m2s. Okay. Then plus, what is left here? 2m2s2. I get my point now. All right. Now, if you look now, before we substitute, you can see, okay, I can take out m2. Okay, let's just substitute first. Let's substitute first. So substituting now, what is our m2s? What is m2s? M2s is what? KB1, M2, and S, right? This is m2s. So let me just put it there. So we just put KB1, then in bracket, M2, then what? Then S, right? Plus 2, open bracket. What is our M2S2? We already have it here, right? This M2S2, right? So that will be what? KB2, KB1, what is next? M2, what is next again? Then what? Then S square. Okay? Then you close the bracket. I get my point. Okay. Now let's continue all over. What is there? 2m2 plus 2, open bracket, what? M2s, abi? What is M2s? M2s is the same thing as KB1, open bracket, M2, close bracket, S, right? Then you close this place. Then plus 2, open bracket. What is M2s2? M2s2 is what? M2s2 is the same thing as this, right? So put what? KB1, oh sorry, KB2, KB1, then what? M2s square. Okay. So with this now, the next thing we'll now do now is to factorize. The next thing we'll do now is to what? Is to factorize. Okay. Next thing we'll do is to factorize. So that if we want to factorize, let's say y bar now, fractional saturation y bar is equals to, I can factorize m2 from this top here. So that if I take m2, open bracket, what will be left? KB1, then what? S, right? Plus 2 open bracket KB1, KB2, then what is left? S square, right? Then all over what now? 2. This time around I will factorize both 2 and m2. So I can factorize 2 and m2. So like this, open bracket, what will be left here? 1, right? Then plus, what will be left there? KB1 and S. Okay, I factorize both 2 and m2, like 2m2. That's what I factorize out to this place. So if I take 2m2, 2m2, just one that will be left. If I take 2, then take this m2, I will be left with what? KB1 and what? S. That's what I write here. Then plus, if I take this 2, I've already taken it out. Then take the m2. What is left here? What is left there? What is left is just KB1, KB2, then in bracket S square. So from here now we can just strike this one out and write down the final equation for Adair equation for a dimeric protein. So that our answer will now be what? KB1 in bracket S plus 2 open bracket KB1 KB2 S square close bracket all over 2 open bracket 1 plus KB1 bracket S plus KB1 KB2 S square close bracket. So this is our equation for Adair equation for a dimeric protein. So for this is Adair equation for what? For a dimeric protein. Alright, so in the next video I will talk about Adair equation for a trimeric protein. Adair equation for a trimeric protein, okay? Adair equation for a trimeric protein.